You clicked on this video because you have seen your production models silently degrade. You know that a single upstream schema change can poison your data and destroy your predictions without a single error log to blame. Today, we are going to talk about how to stop that from happening by shifting your strategy from detection to prevention. You will learn how to enforce schema contracts at compile time and use canary deployments to isolate breaking changes before they ever reach your models. The most common mistake engineers make is treating schema drift as a runtime problem. We build pipelines that ingest data, assume it is valid, and then let the model try to process it. When the upstream source changes a column name or removes a field, the pipeline does not crash. Instead, it silently feeds garbage into the model. The model produces confident but wrong answers. By the time you notice the drift, the damage is done and your business trust is eroded. This is the silent poison that kills data products. To fix this, we need to move the point of failure earlier in the process. The most effective strategy is to shift validation from runtime detection to compile time enforcement. Imagine your data pipeline as a factory assembly line. In a traditional late-binding architecture, the assembly line runs continuously. If a part arrives with the wrong dimensions, the machine keeps trying to fit it in. It might jam later, or worse, it might produce a defective product that passes inspection because the error was subtle. Now consider a different approach, where the blueprint is checked before the machine even starts. This is what policy-aware contracts do in modern frameworks like Scala 3. These tools allow you to define strict structural compatibility rules at the seam between compilation and runtime. When you write your code, the compiler checks if your data structures match the expected schema. If an upstream change breaks that contract, the build fails immediately. You cannot even deploy the code. This means invalid data never enters the execution environment. It is a fundamental shift from hoping for the best to guaranteeing safety through code. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. However, enforcing contracts at the code level is only half the battle. The other half lies in treating your database schema as immutable code. Many teams rely on tools that allow schema drift, such as Azure Data Factory's Allow Schema Drift feature. This feature is robust against source changes because it tries to adapt to whatever data arrives, but it sacrifices early binding validation. It requires complex pattern matching to avoid hard-coded field failures. The result is a system that is flexible but fragile. You might survive a schema change, but you lose the ability to predict how it will affect downstream consumers. Instead, we should look at declarative schema-as-code tools like Atlas. These tools integrate migration linting to proactively identify destructive changes. They ensure that the physical database state aligns with your version-controlled definitions before deployment. This eliminates the silent drift caused by manual changes or missing migration history. When you treat the database schema as code, you eliminate the false sense of stability. You know exactly what state the database is in at any given moment. But even with compile-time contracts and schema as code, you still face a critical trade-off. Rigorous safety demands significant engineering overhead. You might find that strict contracts reduce flexibility for dynamic data sources. Real-world adoption reveals that tooling mismatches can still cause silent drift. For example, mixing Prisma's DB push command with migrate dev can create a situation where the migration history and the actual database state are out of sync. This creates a gap where the system thinks it is stable, but it is actually drifting. This brings us to the most valuable insight of this entire discussion. The most critical failure mode is not the schema change itself, but the lack of synchronization between the migration history and the actual database state. You can have perfect contracts and perfect code, but if the physical database does not match the migration history, you will still face silent failures. The solution is to decouple the ingestion layer from the transformation logic via strict interface contracts. This ensures that upstream data quality issues are caught as data ingestion failures rather than model inference errors. To implement this, you must introduce canary deployments for your data pipelines. A canary deployment allows you to validate schema changes against a subset of downstream consumers before full propagation. You isolate the blast radius of breaking changes to a controlled environment. If the canary fails, you roll back immediately without affecting the entire production system. This approach allows you to test the impact of schema changes on your models without risking the entire pipeline. It is a safety net that catches errors before they become disasters. The combination of compile-time contracts, schema-as-code, and canary deployments creates a robust defense against upstream schema drift. You shift the failure detection from runtime data poisoning to build-time errors. You ensure that the physical database state strictly matches the source of truth. You validate changes against a subset of consumers before they reach the whole system. This strategy requires careful calibration against the specific latency and agility needs of your production environment. You must balance the rigor of early binding with the flexibility required for dynamic data sources. It is worth noting that while the Scala 3 approach offers reproducible benchmarks for structural checks, broader claims regarding productivity gains remain unquantified. The shift-left strategy is not a silver bullet. It requires a cultural change in how you approach data engineering. You must stop viewing schema drift as an inevitable nuisance and start treating it as a preventable failure mode. By enforcing contracts at the compile time layer, you create a system that is resilient by design. The ultimate goal is to stop the silent poisoning of your models. You want to catch errors before they hit the model, not after they have corrupted your predictions. This means revalidating data frame schemas at sync boundaries to catch incompatibilities before data ingestion. It means ensuring that your migration history is always in sync with your physical database. It means using canary deployments to test changes in a controlled environment. When you do all of this, you transform your pipeline from a fragile system into a robust production-grade asset. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.